So in class the other day, I had you look at these simulations looking at Rutherford scattering. And so I'm going to start by looking at the plum pudding model of the atom. This is what J.J. Thomson had proposed the atom looked like after the cathode ray tube experiments. And so what Rutherford did was he took radioactive radium and directed the alpha particles that it emitted at a sheet of gold atoms. And this is what they thought was going to happen based on the plum pudding model. Alpha particles are really, really big compared to electrons, and so the analogy I made was this would be like rolling a bowling ball 100 miles an hour at a marble and then looking at what happens to the bowling ball. So they thought that these alpha particles that you're seeing flying across the screen would just go right through the atom, like you're seeing. Now, this is not what happened. So what actually happened is what I'm about to show you. So this is the same experiment, but we're looking at it using the Rutherford atom, or what we called the nuclear model of the atom. So when Rutherford directed alpha particles at these gold atoms, what he saw is that most of them, if you look at these in kind of the middle here, most of them just went right through, okay? And they would hit a screen at the back of this that would light up, indicating that most of these alpha particles would go right through this thin piece of gold foil. But what you can see is that some of them get deflected. And when I actually click the traces, you can see that some of them are kind of bouncing in a different direction. Now, the reason this is happening is because these alpha particles have a positive charge and they're being repelled or deflected by something. And what Rutherford discovered is that they're actually being deflected by another structure right here in the middle. See how this yellow dot is what is deflecting these purple alpha particles? They're being deflected by another positively charged structure. So if I click on this zoomed in version, you can see that when they get close to that, this is what that yellow dot represents, they get deflected and some of them even bounce back. So part 2 of the experiment is the actual result of Rutherford's experiment, and that's where they proposed what we call the nuclear model of the atom. So what structure led to collision and repulsion of these alpha particles? It's what we now call the nucleus. And so the nucleus is this dense, positively charged structure in the center of the atom. Now, why are alpha particles repelled from this central structure? Well, alpha particles have a positive charge, and this central structure has a positive charge. And we talked about how two things with like charges, so if they're both positive, they're going to repel each other. So why are alpha particles repelled from the central structure? Because they're both positively charged. Now, if I were to make the nucleus of these atoms bigger, you're making it more positively charged. So if I add more protons, which are positive, and more neutrons, which are neutral, you have a larger positively charged structure. So it just makes it more likely that these alpha particles are going to bounce off of something, because now this central structure is bigger, and because there's more positive charge, it increases the repulsion force. So you're going to have more particles being repelled, and you're going to have an increased force of repulsion. So based on this experiment, the actual result is what you see with the Rutherford atom. That's what actually happened. Most of the particles get through, but there are a few that when they encounter this central structure that we call the nucleus, they get repelled or deflected. This was a really surprising result. I didn't click record. Oh, I did. Okay, good.